Spoilers everywhere. Okay, so yeah, that might be a little bit funny because introduction to observables and reactive programming after a whole day of talking about reactive programming, it might sound funny, but okay, let's do this. Just let's talk about JavaScript. So if you want to leave now. Okay, so how many of you have to use JavaScript in your program? Okay, yeah, pretty much everybody. I'm not going to ask who really enjoys that, but yeah, that's fine. So my colleague has this saying that eventually we will all end up in JavaScript. So yeah, that happened for me. Um, Now, what is reactive programming? A front-end guy just appears out of nowhere. I had this question today. Am I going to talk about React.js? No, definitely not. So forgive me, but I also give this speech in slightly different communities. And most of the time what I do is, in these introductions, I say what is the difference between proactive and reactive. I know you guys are already an experts in that, but let's maybe just have a clear view on that. So there's there's a small difference, but very significant one that I will also discuss later between the proactive and the reactive. So imagine that I'm a source of some kind of events and you can listen to those events. Let's say I'm done with this speech. In a proactive approach, I would iterate over each one of you and say, you go get a coffee, you go get a coffee, and so on. While this might be a bit strange because maybe not everybody wants to get a coffee, maybe somebody wants to get a tea, I can become more generic and say, you go do something and you go do something. But there's still something wrong with this approach, right? I should not be interested with telling you on what to do. And that's exactly the thing that happens when you programmed, when you attach the event listeners on the front end to various UI events, like let's say clicks, mouse clicks, or keyboard events. In a reactive approach, we do something a bit different. We obtain a reference to an event, and then we do whatever we want to do with it. The event does not have any immediate handler. It does not have anything attached that would say what should be done whenever this is emitted. It's rather a responsibility of the observers, but I will show that shortly. So just a few words about modern functional reactive programming. It's all about the functional programming and this exact reactive pattern that I just said about, and the observables. So in the front-end world, we have three major libraries: RxJS, the Bacon that was presented already today with Michał's talk when he showed how to write the snake game, and Kefir, which is very similar to RxJS. It's rather a lightweight version of this library. So there is this question: what's the difference between something like an array and just a collection, a static collection, and events? So yeah, both are collections, basically. We can just say something like this about it, and this will have a meaning when it comes to the operators. Now, events. Yeah, events are something that in reactive programming can be considered as collections of stuff that is asynchronous, that happens over time. It's not finite. It has some beginning, but it has no end. I mean, it can have end, but it's not necessary. And arrays are always finite. They are synchronous, at least on the front end in the JavaScript world. Yeah, events may or may not be. So to sum up, this is a programming paradigm that works with asynchronous data streams. And those data streams that we iterate over, that we react to, can be created from UI events like clicks, keyboard events, maybe some gamepad events, because we can also have online games in the browser right now. And also HTTP or the WebSockets communication, which can also be treated as the stream of events. Now this is an example of the speed camera. That's something that I always show to people who are not yet familiar with the observables. Uh, and yeah, let's look at some code. So imagine there is a highway, which we can just simulate here as an interval. So we are the speed camera, and we want to watch only, let's say, 25 cars that are uh, riding on a highway, because we are lazy, right? We just want to look at 25 of them. And then we just, for each of those cars that pass, we only take out the speed. Um, Here I'm just throwing some random speed, and then I filter over those cars, and I only take those that exceed the speed of 70, be it miles per hour or kilometers per hour, doesn't matter. Uh, and the last thing, I am the speed camera. I subscribe to those events, so the cars passing through the highway are events. And for each one of them that exceeded the speed, that got through that filter that is over there, I just log it to the console and I say, hey, you just exceeded the speed. Now, who is an observable? Who is observer here? So, yeah, the speed camera is an observer. The highway with the cars is an observable. That's simple thing. And yeah, and there's a reaction to the events emitted by the highway, so by the observable. So you saw map, filter, reduce and take. Yes, we also have it on front-end world. We have it in JavaScript. Um, and of course, our RxJS API, it's much more complicated than this. We also have the operators that are well known from the Java world. Let's say RxJava or the other APIs that are supported for other programming languages. Now, when it comes to the UI examples, of course, just an example of highway is a very trivial one. It doesn't show the real world scenario of using those. I have 4 examples of the problems that I saw, that I met in my career, that were solved with reactive streams. And I will just show them to you and show you the code and show you how this can be just written cleaner and better than the usual approach that is present amongst most of the front-end developers yet. So the first one, it will be a start, stop, and reset counter. A very simple thing. Is it that usable? Probably this approach will be usable in games that can be also implemented on the front end in the browser. And actually for this one, I want to switch immediately to the browser. So let's start maybe with the code. On the top, we just simply obtain references to our buttons that will be source of streams, of the event, sorry. Then we have those streams that are created out of these buttons and out of the events that can be triggered by the user, like click events. And when it comes to this part, it's just a simple code that takes the click events of the stop button, and also takes an interval of 100 milliseconds, and each 1 second it emits an event which is taken until the stop button is hit. Now I will show you in a minute how this works when I click those buttons, but the thing is that I accumulate those values that are emitted from those streams, and based on some simple logic, whether what kind of value was emitted, I can start, stop, or reset the counter. That's quite nicely solved here. So let's say I just click a start button and this clock starts to tick. Anytime I can say I want to stop it, and then of course I can resume it. It will still keep that state that is maintained within this scan method here. So it will continue from the place that I stopped it on. Now I can also click on the reset, it will start from 0. So I know that this is quite simple, and it's not maybe something that you would use on daily basis. You are not going to write these things every day, but it shows that that the solution provided here, only 18 lines of code, is much more simple than the solution that you would do on simply binding to events with, let's say, just pure DOM API or something like jQuery. It doesn't introduce any global state values, at least for the current state of this clock. Of course, there are the references to the elements and to the streams, but that's different. And yeah, it maintains the states within these functions. Now, let's go to something more useful. So, querying an API endpoint for data. Now, that's something that you would write probably more often than the clocks. So imagine that your task is to write a search box. You want to query some API and you want to get a list of results, just a simple search box. So what you would usually do is probably you would use some kind of framework like React or Angular or something like that, because you know it's so fancy right now. Or maybe you would just use a pure JavaScript API, the DOM API. And at the moment that you create a search box, you attach an event and event listener, and then you just only take the values from the search box and you send an AJAX request. So what happens when you give this to the QA team? What's the first thing they do? So they hammer it, right? They just click a lot. They type a lot into the box. And what usually happens in those simple implementations? I can see at least 3 problems with the most of the implementations that exist out there in the wild. So first of all, on every keystroke, on every letter that is added to the search box, an AJAX request is sent. And that's not a very good situation for our server, because we don't want to send a request on every keystroke. We don't want to flood it with the requests. That's the first problem that people in most cases don't think about. The second problem is the requests that are sent to the server with AJAX are asynchronous, and we have absolutely no guarantee when they will come back and in what order. So it might be a situation that you start typing and a request is sent for first 3 letters, then you type another 5 or 6 letters because you just have some long query, and actually the first request that was sent comes after the second request that was sent, and you end up with the inconsistent state. You end up with the result that was that is a response for something that was sent before. So you get a result for those 3 first letters that you typed in. And yeah, actually it's pretty common. Most of those naive implementations of the search boxes don't take this into account. So what I wanted to show you here is, again, the stream-based implementation. Now it uses quite a handful of those RxJS operators. So the first problem that we want to solve is all about not sending a request on every keystroke. We want to somehow debounce on the user keystrokes. We want to avoid sending the requests just after every letter. So the first operator, debounce, it takes a parameter of 400 milliseconds, and it says start pushing those events to the next operator only after there are 400 milliseconds of no input from the stream. So that's the first thing that we solved here. We don't emit an event after every keystroke. We can just safely say that users are typing the letters faster than 400 milliseconds between each of those letters. Then of course, we map because there's a keyboard event emitted, and we want to take a target, So that's the search box that we have. That's the DOM element. And we want to take the value out of it and send it to the next operator. Now, distinct until changed is quite interesting one. Although I use the input event here, which according to the DOM specification and to the documentation of this, the input event is only triggered when there are letters or symbols being inputted into the input box. It used to be before IE9, because yeah, we have to also support IE. That there was no input event, there was a keyboard event, key down event, sorry, that had to be used. And key down event used to work the way that even if you are focused on the search box and you push the left or right arrow on the keyboard, this event would be generated. So in practice, this would mean that whenever I'm typing something and I just want to reposition my cursor, it would emit an event, right? It would, again, it would go through this pipe, and without this operator, this would go further. What distinct until changed does is that it checks whether the current event, the current value that was emitted from the map is the same as the last one. If it is the same, then it stops here. It doesn't send it further. If it's not, if it's changed, then it pushes it through the pipe to the next operator. And when it comes to the clear list, the do, that's just a simple cleaning of the list that I just want to erase the previous results. Then I also filter. I don't want to send the empty strings. I don't want to search by the empty string. That's obvious. What flat map latest does, that's exactly the solution for the thing that I talked about when it comes to the order of the results coming back. Now that's interesting, but flat map latest actually can switch to the latest observable that is emitted from inside of this operator. Here I send a request with Axios. That's a simple front-end library for sending requests. And I can wrap it into the observable with this from promise operator. So it means it gives me a guarantee that if I send another request, which is like the last one in the order, then here in this map, I will always have the results from the last request. I will never end up with the request that was sent before and that for some reason had some lag and just came after the other requests. And then, of course, at the end, I have to subscribe to it and render the response. I want to show you this. So I'm just looking for the JavaScript repositories on GitHub. So yeah, when I type something, of course, yeah, well, it works. Now, I could show you that if I do something and then remove it quickly, let me turn on the console. So you can look, the HTTP request will be logged on the console. So if I remove something, there's of course, there is a event generated because this value changed, and the request is sent. Now imagine I add like maybe 3 letters and then I remove it quickly. Nothing happens because it's still the same value that is inside the search box. Of course, if I add 1 letter, 400 milliseconds pass and another request is sent. So I don't have this problem. I'm not flooding the server with the requests after every value change. And also, just look, when I type quickly, I'm not sending a request after each keystroke. Only now it was sent. Okay, so now another problem another challenge that I had in one of those projects that I'm working on is about changing the UI elements position by dragging those elements. So imagine that we are building a web application that is somehow similar to the desktop applications. It contains those toolbars that can be dragged around. And when it comes to this, there is no simple API, there is no simple event in the browser that would allow you to model this behavior. There is, of course, a drag and drop API in modern browsers, but don't confuse it with that. The drag and drop API is all about data transfers. It's like you can drag a file from your desktop into the browser on some field, and then it reads the data that is inside. It doesn't have anything to do with changing the position of an element. At least not the one that would allow you to just change the position while dragging. It may transfer the data that would say that if you drag from here to here, then it immediately jumps to another place, but it's not about the continuous flow of the positions. So this one is also quite simple when it comes to the amount of code. I can assure you that the same logic written with just bare JavaScript or jQuery events, because I saw this implementation in jQuery too, was at least twice longer than this one. From a high level, it's all about listening to the mouse down events on some element that we want to drag, and then using the flat map, of course, I'm listening to the mouse move events that are only listened to the moment that the mouse button is released. So the operator that says take until mouse up. So imagine that you click, you drag, that's a mouse move, and then you just release the mouse button, mouse up. So yeah, all these things are subscribed to, and the position of the element is changed. For this one, I also have an example. And, oops, sorry, it's not this one. Yeah, it's this one. So as I said, there is a toolbar inside the application, and it can be easily dragged around. So it changes the position. It has some position fixed on the window, and this can be easily changed. It's not that trivial challenge when it comes to writing it without the streams, and it's definitely not that readable. Now for the last one, which is also something about dragging, it's about the resizing of the elements. So that's a very similar logic here. It also has to do with listening on the mouse events and taking it until the mouse button is released. So this one is about, just imagine that you have some kind of reader and you want to show some thumbnails of the next pages that are displayed next to it, and you want to enable making it bigger or smaller. Now this resize also, this is very similar to the last example. In the DOM API or just in the browser, we have no simple means of resizing the divs just by clicking on it and dragging. So actually this solution enables it. So yeah, you might say that just looking at those operators, at those asynchronicity, you might have seen this pattern already somewhere. And yeah, while reactive programming in frontend is quite new topic, it hasn't been used for many years yet. We have seen something similar in promises. So yeah, promises versus observables. You might say that some of those things, at least all those HTTP requests, might be maybe modeled with the promises, but what are the real differences between them? So basically, when it comes to when they start to execute. So promises are hot by default. Whenever you provide a code that has to be executed within the promise context, it starts executing immediately. When it comes to observables, they are cold by default, but can also be hot. You might also know it from Rx Java or Scala that we have to attach the subscribe function to actually start executing the code that is defined inside the observable, if we of course create the observable by ourselves. Now, promises cannot be retried. When the promise fails, it just fails and that's it. Of course, we can attach our handlers and attach some workaround logic that would retry the code that we wanted to execute, but there is no simple means of retrying. When it comes to observables, they can be retried. There is even a simple operator that does that. I saw examples of observables being wrapped around the WebSocket references, I mean the WebSocket communication, and it was used for an application. It was the progressive web app, so it was something like a mobile app but executed within the browser, and the reason for that was to maintain the connection. So each time there was a push-based approach, so the data was pushed through the WebSocket to the browser, and whenever the connection was lost, like let's say you are moving between the buildings, then it would retry the connection on some few seconds basis, like every few seconds it would retry. Whenever it worked again, then it would just push the data into the pipe again. The promises cannot be disposed or cancelled. So as I said, this is a consequence of the promises being hot. When they start executing, they have to execute to the very end. The observables can be disposed. Actually calling subscribe on an observable returns a reference to a function that when called gets rid of the observable, emits the done event, and basically all the resources are freed up. So that's also an advantage of observables, that you don't have to unsubscribe from the events in a fashion that is known from native DOM APIs, but you just unsubscribe from the observable, and every event listener that was created under the hood is being disposed of. Yeah, the last one. Oh, come on. The observables may or may not finish. That's the consequence of what I said about being disposed to. Yeah, you might say, can I live without all this crazy stuff on the front end? Because front end, yeah, come on, observables, maybe not. Yeah, sure you can, of course. In the same way you could live without ES6, which is the next implementation of JavaScript. Like you could live without it like 1 year ago, maybe 2 years ago. Right now, it's quite difficult to live without it. It's used widely on a complex user interfaces. When it comes to the libraries, Angular 2, for example, uses it. Whether this is necessary out of the box, this can be discussed, because maybe we could just get along with the promises and it would also work out. But they wanted to add it out of the box as a support for this library, so yeah, it's there. There are even libraries like Cycle.js, which is all about the asynchronous data flow, all about the observables that create the whole application. And when it comes to the companies that use it, first of all, I would say about Netflix. So actually the front end that you see in your smart TV or on your laptop or in your mobile is built with observables. All this stuff that is there, the search boxes, the features of going into the movies and playing them immediately, and then all this stuff about the left menu that disappears when you spend a decent amount of seconds over the movie that starts playing. It's all built around observables. And they have a very strong team of developers that do that. and they are probably the best people to consult on those problems, on those challenges. I learned a lot from them on the conferences and from YouTube, because they uh, share this knowledge in a very, very good way. When it comes to some advices, of course, don't overuse it. It might be tempting to create the whole application as one huge flow of the data streams that is merged or combined into one huge stream, but that's not the best idea, and please don't do that. It's better used for individual features, for the things that you saw, like dragging things around, like writing those search boxes, but definitely not create the whole logic like one huge stream. So where would I use it? Yeah, spreadsheets. Spreadsheets were like Google spreadsheets were implemented with something quite similar. Events that come from the mouse or the keyboard, which can be used into modeling the data. The logic of the games, like we saw with the snake game, with Michał's presentation. Enhanced forms, so that's again about debouncing the user input and handling the AJAX. And complex UI interactions, that's all about dragging around and resizing. What are the advantages? Of course, the functional style. Of course, there are no global variables. The state of our streams is maintained within those operators. The pure functions, the lambdas that we just pass into, can be easily tested. So that's one of those advantages. When it comes to actually testing the RX code, the declarative code is not that simple, because we have to somehow, in most cases, mock up the clock or the time flow. It's not trivial, but it's also doable. And yeah, it solves the challenges that in a traditional approach would be quite difficult to solve. So there are also some links. I will share this presentation, and they show mostly the examples from the front end. Yeah, so that's it. If there are any questions.
Okay, so the question is maybe a little bit off topic, but we have a lot of different libraries on the UI. We can claim that when we put the word and add the GS, we have this library. And yeah, how you actually finding what you should use or what you shouldn't use? Do you have some experience how to avoid the pitfalls and not to use the technology that will not play well together or something like that?
What do you mean, like the frameworks or the libraries that
Particular
only
libraries.
support?
We have a lot of libraries, as you said, from Eric's word. So
Yeah, so okay, so that's a good question, because actually I showed you the examples from RxJS, which is quite large library. It consists of really dozens of operators. In reality, an average developer would not use more than 10 of those operators, because they are most widely used, and they cover most of the cases that are required. In the project that I'm working on, I don't actually use RxJS, I use Kefir. Kefir is not well known yet, but this is like a lightweight implementation of the same thing. So yeah, so that's all about just taking the right tool for the right job. I never needed more than 10 operators actually, and they're all embedded in Kefir. They even have almost the same names. I mean, in most cases they have the same names. Sometimes an operator like flatmap latest is it's called different in Kefir. I cannot remember right now, but there's a different name for this one. But the things like map, filter, reduce, scan, it's all the same. And the cooperation between those libraries and the view frameworks like Angular or React are also fine. So there is no problem of using those together.